Now the second part is that we have some new type of ports. So we now have some fiber channel over Ethernet port types. So when looking at our port types, if I want to configure a port and I right click a port, I can now tell this port, hey, you are no longer an uplink port, but you are now an FCoE uplink port. What that means is this is still a SAN uplink port, but it's not using native fiber channel, it is using Ethernet as its transport layer. So that is the biggest difference here in my uplink port. I'm not using fiber channel as the encapsulation, but I'm now using Ethernet tunnel interface where I tunnel fiber channel traffic across, which is FCoE. Or I can say I connect FCoE directly to the fabric interconnect and consider this as an appliance port. Now the issue with this is if I reconfigure my port to be an FCoE uplink port, it is an Ethernet port, but it disappears from the LAN tab, so I'm not seeing it here, but I do see it here. So here I have my FCoE uplink interface. Now the fun part of this is that I cannot do Ethernet transport across this. I can just do FCoE transport across it. So as we mentioned before, if we have a box running FCoE and we connect it to a switch running FCoE, so I'm just drawing one link, by the way, this is one link. And in that link, I transport multiple VLANs. So normal data VLANs, the red wires, so normal VLAN 100, 200, 300. And then across that same wire, I have an extra VLAN, VLAN 400, which is my FCoE VLAN. And in that FCoE VLAN, I transport fiber channel packets. So besides having normal VLANs crossing the link, I now also have fiber channel traffic crossing the link. So this is the normal operation of running a fiber channel over Ethernet link. That is the whole beauty of the whole concept. So we run data traffic and storage traffic across the same wire. Therefore, FCoE is just an excellent technology for access layered links. Remember, I have my access layer switches here in the network, and I have some core switches on top of here. This is a typical data center design if you read the Cisco guides. So we have some Ethernet uplinks to each of the network uplink switches. There we go. And we also have some fiber channel uplinks for fabric A and fabric B going to my storage core switches. This is a typical data center design. So I have my access switches and core switches. So core, both Ethernet and fiber channel switches. In the past, we also had access fiber channel switches. So now in our server, we place a CNA. So with that CNA, it becomes possible to run fiber channel over Ethernet. And because we can do that now, we can drag a wire, fabric A, fabric B, on the CNA, and across that link, we can build a tunnel interface for our fiber channel traffic. So we use a single wire going to the server, or two wires for redundancy, but we use a single wire to the server for both LAN and storage traffic. Now the implementation on the UCS only allows for FCoE uplinks, meaning a full link only used for FCoE traffic. So in this case, this design will basically be the same. So if we consider this to be a blade server now, and this is my fabric interconnect, I still have the same LAN uplinks and SAN uplinks, except that this green uplink is now no longer a fiber channel link. It is an Ethernet link where fiber channel traffic is running across. So I still have a dedicated link for storage traffic, but it is using Ethernet encapsulation, which can be useful in some deployments. For example, if I would have a Nexus 5K or a Nexus 7K running on top of the fabric interconnect layer, then I would be able to terminate my fiber channel traffic inside that switch. And I do need to drag another link, but I can still use the same physical encapsulation. So there are some examples where this would be beneficial. It's not in all use cases beneficial. To explain the scenario with the C-series blade server. That's going to be using the same technology as the blades. So I have a fabric interconnect here. Imagine that I have a separate C-series server here, so C-series server 1. In that C-series server, I have a CNA adapter, meaning I can do fiber channel and Ethernet on top of that adapter. And I just drag a fiber channel over Ethernet link, just like a blade does towards its fabric interconnect. But this is not a fabric interconnect, this is just an access switch, just a nexus, any nexus. So this is my C-series, the C-series blade server, you say. But this is a rack server. So C-series is the rack server. In the blade server, when I'm connecting it behind the fabric interconnect, so let's say I have a C-series server here. I'm doing the same thing. So I drag my, imagine that I have my Cisco VIC card installed here. That means that I can drag the links directly to the fabric interconnect. And because I do that, I can use the same FCoE technology that the blades can use. The blades do exactly the same thing. So they do exactly the same. They drag a fiber channel over Ethernet connection between the CNA and the fabric interconnect. And the C-series server will do the same thing. So it will drag a FCoE connection between the C-series server and the fabric interconnect. As said before, FCoE is not an end-to-end protocol. It is just a hop-by-hop protocol. So I just tunnel fiber channel frames across an Ethernet circuit. So here, the Ethernet packet is decapsulated. A fiber channel frame is seen, and then the fiber channel frame is being processed just like it would in any other normal fiber channel switch, or NPV switch for this matter. Now what we change here now is, instead of doing a native fiber channel uplink, we are running a fiber channel over Ethernet uplink. Meaning that this is not an F port, a fiber channel over Ethernet F port. This is going to be an E port or an NP port in most cases, because I'm running NPV mode, remember? So this is going to be either an E port or an F port going down here, depending on on which mode my fabric interconnects are running. So as said before, the implementation in UCS 2.1 does not allow the transport of both data VLANs and storage VLANs, so FCoE VLANs, on the same link. I need to have a dedicated link for FCoE traffic and a dedicated link for my LAN traffic. This will work very differently because the Ethernet link will not be pinned to an uplink. This link, this Ethernet link, oh yeah, it will be pinned to an uplink. So I'm running data VLANs across here as well. So let's say the pinning is going towards that uplink. But the FCoE traffic is locally terminated. There is a local virtual fiber channel interface, VFC interface, on the fabric interconnect. So that FCoE traffic is being caught and locally processed. And by processing means it will have separate pinning. So the VFC interface that runs on top of the Ethernet link has separate pinning and separate forwarding characteristics. So in my case, my VFC link will be pinned to a storage uplink, and I don't care if that's an FCoE link or a fiber channel uplink. So same type of pinning, it's just that I'm not forwarding FCoE packets out of an uplink. I'm never forwarding FCoE packets straight from the server out of the fabric interconnect. I always terminate fiber channel traffic locally, and then I start looking at the packet. What do I need to do with it? Well, I need to pin it to a storage uplink. So that is FCoE. How do I configure that? That's actually quite easy. So what I first want to do is I want to remove one of my links that is currently in the uplink port channel on Fabric A. So I have two links there, Ethernet 111 and 12. I'm going to disable interface Ethernet 112. And I'm going to log into, what's the IP address? 8, I think. So this is my link. It's in port channel 3001, which is a VPC, but I don't really care about that. I'm just going to take this uplink interface, which is, so currently I have this set up. I have my two fabric interconnects. I have a blade system connected there. And I have two Nexus 5Ks as my uplink switches. Fabric interconnect A and fabric interconnect B. And they are connected via a VPC to each other. So this is a VPC and this is a VPC. So this is my link. Where is it? 11 and 12. 11 and 12. I disabled 12 and that is link 11 on this Nexus 5K. So this link I'm going to turn into a fiber channel over Ethernet uplink. So I have some fiber channel targets or some fiber channel devices on this Nexus, meaning I can use this now to push that down towards my Cisco switch, towards my UCS. I also am running local fiber channel uplinks here. So in the SAN tab, I have a fiber channel port channel here that is disabled for some reason. We have multiple. 31, 32. It's not running in trunking mode. It's an F port, but it's not trunking, so it's just in vSAN 2200. So let me disable these interfaces. So I want to disable my fiber channel uplink interface towards the switch. So what I'm doing is, currently I have the following setup. No, I have the following setup. I need to disable 11, sorry. What I did is I have two links to two Nexus 5Ks. Along those two links, I also have two fiber channel links. So this is my connectivity on the fabric interconnect. What I'm going to do is I am going to replace the fiber channel uplinks with an FCoE uplink interface. So in that case, I only have one Ethernet cable between the fabric interconnect and the Nexus. So I'm going to take this port out of the port channel And I'm going to take the same port and I'm going to use that to create a FCoE uplink. What I'm going to do is I just disabled these fiber channel ports. Here, the 31 and 32, they're now disabled. So if I check on fabric A, I no longer see the Cisco entries here. If I do the show FCNS database here, I do see my blades logged in. Here, this is another fabric, so this is fabric A, and this is fabric B. Fabric B still has the host, fabric A doesn't. Now, to make sure that I can use an interface, I'm going to enable this port back again. It's up and running. Now check on fabric A. I should have a port which sets down, which it doesn't because I need to disable it. I'm going to disable link 11. And that turns out that now this link is down. You see here it said P for participating, and here it says D for down. So I can now reallocate interface 11 for running fiber channel over Ethernet. Do I have FCoE configured? Yes, I have FCoE already prepared on this switch. So I'm running vSAN 2100 and I'm running that in VLAN 2100. Now fortunately that is also the case here on the UCS. So I'm first going to reallocate the interface. So the current uplink interface, that interface 1/11 on fabric A, that is configured as an uplink port, an Ethernet uplink port. I now want to move this uplink port for being a fiber channel over Ethernet uplink port. So I'm going to go here on fabric A, fabric interconnect A. I'm going to port 11. It says network right now, so network uplink port.